Okay, today we're going to address the hard part of understanding our kinetic energy amplifier invention, the math. That's going to be especially hard for us because some of the formulas and the laws that we would need to reference to make this work don't exist yet. So we better get started. And the place to start is the law. And in particular, the law of conservation of energy. The law of conservation of energy says that energy is neither created nor destroyed. It simply changes forms. For example, we can say potential energy is equal to kinetic energy. And therefore, energy is merely changed forms. It's not bigger, it's not smaller. And if we change it back, it's the same thing. All the different forms of energy are the same when you compare them one to the other. The formula in particular that we're going to be looking at is going to be the potential energy, as it's most like magnetism. The letters in this formula, mgh, mean mass times gravity times height. In this case, it would be heights from the surface of the earth or a table or however high you hold something up. mgh is a fact. We know that that's true in relation to height and the surface of the earth. However, when you drop the ball, does it float off into space? No, gravity keeps pulling, and that's what holds it to the surface of the earth. The formula as it is now describes the potential energy as being used up. When, for example, the ball lands on the earth, it stops moving. However, gravity doesn't stop pulling. So really the potential is not used up, it just ran into an equal and opposite force, the ground. So if we want to have a more encompassing idea of how gravity relates to matter, we need to update it to include all the different situations that might occur. That also allows for the movement described in the kinetic energy amplifier invention. Much like gravity, magnetism will hold these balls to the side of a dish or a bowl, the same as gravity would hold us to the earth. So, since gravity and magnetism are so similar, let's use our formula for potential gravitational energy to make our formula for potential magnetic energy. So let's look at the formulas and what they mean. The mgh means mass times gravity times height. With kinetic energy, it's 1/2 times mass times velocity squared. Just for a reference. For us to make our own formula, we have to understand what these variables mean. For example, the mass times height times gravity. The mass and the gravity have a relationship. And the two numbers, the variables, mathematically define that. That's going to be the same, I think, with our magnetism, but we won't be using gravity. Instead, we'll be using magnetic flux in this formula. Well, what's magnetic flux? Well, flux is gauss. The strength of a magnetic flux field is measured in gauss. So we can say gauss instead of gravity. Now, our magnetism is going to have the same exact relationship with mass that gravity does. So mass is not going to change here. We can still have the mass. However, the height is not going to work for us. Height means up and down. With magnetism on Earth, it could be sideways, it could be vertical, it could be through walls, it could be any array of things. Height is not going to work. We need to use distance. A magnet's strength is the strongest right against it. The closer you get to it, the stronger it gets. The further away you get, the more it loses its strength. Same with gravity. So we can use numbers that are similar between gravity and magnetism. In this case, since magnetism is such an exponentially smaller force in a handheld magnet or a permanent magnet than is gravity, we can say that gauze times mass, that relationship is the same, gets weaker at a distance. And the further away you get, the bigger that bottom number, the smaller is your relationship. So, when you come right down to it, that's it. Our law of conservation of magnetism is mass times gauze divided by distance. Now, if we consider the law of potential gravitational energy, MGH, when we use the variable height, that works on the surface of Earth with something small, a ball or a truck or a boulder. But it's an incomplete description of what gravity is like and its relationship with mass. What about a spaceship? What about a moon, a satellite? If we want this formula to be completely correct, then we need to update the formula for potential energy to consider distance, like we did our magnets. Then we can say mass times gravity, that relationship is always the same, divided by distance. In this case, it's not the distance from the surface of the Earth, it's the distance from the source of the gravity, the core of the Earth in this case. Gravity is not consistent between planets, but it's consistent based on mass. Instead of considering Earth's gravity, we consider gravity as a whole. Now our formula is complete and includes all the different aspects of a relationship between gravity and mass. In this case, the MGH is still true, but it's only a part of a much bigger formula. You'll see next, we'll talk about some of NASA's figures and how they use gravity. What we're trying to do is no different than using a planet's gravity to slingshot a spaceship. Just we're using it in a little bit different way on a very different scale. In space travel, a gravitational slingshot maneuver is fairly common. It has been used successfully on several space missions that we're all familiar with, from Apollo 13 to Voyager 1, which you see here, and also for the Cassini space mission. And of course, different planets have different specific numbers that fit into the formulas if you want to use their gravity. However, the mathematics can be described several ways with formula. One might say this. One could also simply say this. However, it would be very difficult to argue that it was quack physics or that it wouldn't work, because it has worked, and there is math to support it, just as there is my invention. So when you compare a gravitational slingshot movement with my kinetic energy amplifier, the differences are not extensive. In space travel, the moving craft is on the outside of the source of energy. With our amplifier, the inside rotates. So, instead of using gravity, we use magnetic flux. Very similar in nature, they behave practically the same way. And there's a difference in the scale. When you start talking about planetary gravity, you're talking large forces. For an earthbound permanent magnet, not so much. However, the figures and the math work the same way.